In the spring of 1943, above the Solomon Islands, a Japanese Navy pilot climbing hard in his Mitsubishi Zero watched an American fighter below him. The enemy aircraft was distinctive: inverted gull wings, a massive radial engine, the new Chance Vought F4U Corsair. The Japanese pilot had heard reports. The Americans called it a fighter, but it looked heavy, almost brutish compared to the elegant lines of his Zero. He initiated his attack from above, secure in the knowledge that had served him well throughout the war. Altitude belonged to the Nimble. The Zero could climb nearly 3,100 feet per minute. Its lightweight construction and powerful engine-to-weight ratio made it one of the finest climbing fighters in the Pacific. When combat turned vertical, Japanese pilots held the advantage, but this time something went wrong. As the Corsair pilot spotted the diving Zero, he did not turn away or attempt to outrun the attack horizontally. Instead, the big American fighter pulled up sharply and climbed. Not the labored gradual climb the Japanese pilot expected from such a heavy machine, but an aggressive, near-vertical ascent that defied everything he understood about American fighters. The Zero followed, pulling its nose skyward, confident in its superior climbing ability. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. For a few seconds, the gap between them closed. Then it held steady. Then, impossibly, it began to widen. The Corsair was climbing away from him. The Japanese pilot pushed his throttle forward, coaxing every bit of performance from his engine, but the American aircraft continued to pull ahead, climbing through 3,000 feet, 4,000 feet, 5,000 feet, gaining altitude faster than his Zero could follow. When the Corsair leveled off and rolled back toward him with speed and altitude advantage, the Japanese pilot broke off, diving away in disbelief. This was not how American fighters were supposed to perform. The Americans built heavy, durable machines optimized for speed and firepower. The Japanese built light, maneuverable aircraft that could outclimb and outturn anything in the sky. That had been the pattern since Pearl Harbor. That had been the foundation of Japanese fighter doctrine. But now, something had changed. The aircraft was the F4U Corsair, and its ability to dominate the vertical dimension of combat would become one of the most devastating tactical advantages in the Pacific War. What Japanese pilots could not have known, watching that bent-wing fighter climb away from them, was that they were witnessing the result of American engineering philosophy taken to its logical extreme. Not just power, but overwhelming power. Not just performance, but performance that redefined what a carrier-based fighter could achieve. The story of the Corsair's climb performance is not simply a tale of superior machinery. It is the chronicle of a psychological shift, the moment when Japanese pilots confronted an opponent that violated every assumption about American aircraft. Through thousands of engagements across the Pacific, they would learn that when a Corsair pilot chose to fight in the vertical, there was nothing a Zero pilot could do to change that. The Americans had seized control of the sky itself. The genesis of the Corsair dated to 1938, when the United States Navy Bureau of Aeronautics issued specifications for a new carrier-based fighter. The requirements were ambitious to the point of seeming contradictory. The Navy wanted a fighter capable of exceeding 400 miles per hour in level flight, an extraordinary demand when most contemporary fighters struggled to reach 350 miles per hour. But speed was only part of the requirement. The aircraft needed low stalling speed for carrier operations. It needed range exceeding 1,000 miles. It needed heavy armament. It needed the structural strength to withstand carrier landings and combat damage. The Navy was asking for an aircraft that combined the speed of a racer, the range of a scout, the firepower of a bomber interceptor, and the ruggedness of a military workhorse. Chance Vaught's chief designer, Rex Beisel, and his engineering team made a decision that would define the Corsair's character. They would build their fighter around the most powerful engine available, the Pratt & Whitney R2000 800 double wasp, an 18-cylinder two-row radial, producing 2,000 horsepower, nearly double the output of most contemporary fighters. This massive engine would provide not just speed, but acceleration, climb rate, and the ability to carry heavy loads while maintaining combat performance. To extract maximum performance from this power plant, Beisel's team designed a 13-foot 4-inch diameter propeller, the largest ever fitted to a fighter aircraft. This created an immediate engineering challenge. How could they provide sufficient ground clearance for such a massive propeller while maintaining the structural efficiency necessary for carrier operations? The solution became the Corsair's most distinctive feature. Rather than using conventional straight wings, the team created an inverted gull wing design. The wings angled downward from the fuselage before leveling out, creating a distinctive M shape when viewed from the front. This configuration allowed relatively short landing gear while providing adequate propeller clearance. The anhedral angle, where the wing met the fuselage, also created optimal aerodynamic conditions, minimizing drag at the wing root junction. The prototype XF4U took flight on May 29, 1940, piloted by Lyman Bullard Jr., Vaught's chief test pilot, from the factory airfield in Stratford, Connecticut. On October 1, 1940, during a test flight between Stratford and Hartford, the prototype achieved a ground speed of 405 miles per hour, with tailwind assistance. The aircraft made headlines as the first single-engine American fighter to reach this milestone. Its actual maximum level flight speed was 378 miles per hour at 23,500 feet, still exceptional performance for 1940. But speed alone did not tell the full story of the Corsair's capabilities. The combination of the massive R2800 engine, the efficient airframe design, and the lightweight structure gave the aircraft remarkable climb performance from its earliest variants. While the prototype's exact climb rate was not widely publicized during testing, engineers understood they had created something exceptional. The power-to-weight ratio exceeded anything American naval aviation had fielded. Production F4U Corsairs began reaching operational units in late 1942. Marine Fighter Squadron VMF 124 received the first combat-ready aircraft, deploying to Henderson Field, Guadalcanal, on February 12, 1943. The squadron's pilots were eager to test their new mounts against the legendary Zero fighters that had dominated Pacific skies since Pearl Harbor. The Corsair's combat debut proved inauspicious. On February 14, 1943, during what became known as the St. Valentine's Day Massacre, Corsairs suffered a disastrous first engagement. 9 American aircraft were lost, including 2 Corsairs, multiple P-38 Lightnings, P-40 Warhawks, and bombers, while Japanese defenders lost only a single Zero fighter. The 9-to-1 loss ratio in Japan's favor was so severe that daylight bombing missions to Bougainville were temporarily suspended, pending tactical reassessment. This engagement demonstrated a crucial lesson. Superior technology alone could not guarantee victory. The Corsair possessed better speed, better climb rate, better firepower, and better structural strength than the Zero. But Japanese pilots were experienced combat veterans who understood their aircraft intimately. They knew how to use the Zero's tight turning radius to negate an opponent's advantages. They knew how to force American pilots into slow-speed dogfights where Japanese maneuverability dominated. American pilots adapted quickly. They learned that the Corsair's strengths lay not in trying to turn with Zeros, but in what became known as boom and zoom tactics. The Corsair could not outturn a Zero in slow-speed maneuvering, but it could outdive, outclimb, and outrun any Japanese fighter. Proper tactics meant maintaining speed and altitude advantage, diving on enemy aircraft, firing a burst, and using superior speed to disengage before the enemy could respond. Most importantly, they learned to fight in the vertical. When combat situations allowed, Corsair pilots would zoom climb after an attack, using their aircraft's superior power to regain altitude quickly. Japanese pilots attempting to follow found themselves watching the American fighter pull away, climbing at rates their Zeros simply could not match. This was the beginning of a tactical revolution that would define Pacific air combat for the remainder of the war. Second, Lieutenant Kenneth A. Walsh of VMF 124 became the first Corsair ace on May 13, 1943, mastering these new tactics and eventually achieving 21 victories. He later recalled the fundamental principle that governed Corsair combat operations. Altitude was paramount. Whoever had altitude dictated the terms of the battle, and there was nothing a Zero pilot could do to change that. The F4U could outperform a Zero in every aspect except slow speed maneuverability and slow speed rate of climb. Therefore, Corsair pilots avoided getting slow when combating Zeros. This tactical doctrine, learned through hard experience over the Solomons, represented more than just good flying technique. It reflected a fundamental shift in the nature of Pacific air combat. For the first 2 years of the war, Japanese fighters had generally held climb advantages over American aircraft. The F-4F Wildcat, while rugged and capable, climbed slower than the Zero. The P-39 Airacobra and P-40 Warhawk struggled at altitude. Japanese pilots had grown accustomed to being able to climb away from trouble or to attack from above with relative impunity. The Corsair changed that calculation. While early combat experiences showed that Zeros could still climb with Corsairs under certain conditions, particularly at lower altitudes and speeds, the American fighters' power advantages became increasingly apparent as pilots learned to exploit them. A Corsair pilot who maintained speed could climb away from almost any Japanese fighter. A Corsair pilot with altitude could dive, attack, and climb back to safety before Japanese fighters could react effectively. The early F4U-1 variant, which equipped most Marine squadrons through 1943 and early 1944, had a climb rate of approximately 2,890 feet per minute at sea level. This was already respectable performance, roughly matching or slightly exceeding the Zero's typical climb rate of 3,090 feet per minute, depending on specific models and conditions. But the Americans were not satisfied with mere parity. As the war progressed through 1943 and 1944, the Corsairs' reputation grew. Marine squadrons in the Solomon Islands, flying from hastily constructed coral airstrips, exploited the aircraft's ruggedness and power to devastating effect. The Corsair proved capable of absorbing battle damage that would have destroyed lighter Japanese fighters. Its 650 caliber Browning machine guns, 4 inboard guns carrying 400 rounds each and 2 outboard guns carrying 375 rounds each, totaling 2,350 rounds, provided overwhelming firepower. Japanese pilots began reporting encounters with the distinctive bent-wing fighter with a mixture of respect and frustration. The Corsair was fast, it was tough, it hit hard, and increasingly, it could climb. Reports filtered back to Japanese command describing American fighters that refused to engage in turning combat, instead using vertical maneuvers to control engagements. Zeros would attack, only to watch their targets climb away. Ki-43 Hayabusas, nimble and light, found themselves unable to catch diving Corsairs that pulled up into steep climbs. The psychological impact was subtle but significant. Japanese pilots had built their tactical doctrine around specific assumptions about American aircraft. Americans built heavy, durable planes that were fast in a straight line but poor climbers and turners. The solution was to force them into slow-speed combat where Japanese maneuverability dominated. But the Corsair, while still unable to turn with a Zero at low speeds, was proving capable of avoiding that trap entirely. Then, in early 1945, a new variant began reaching operational squadrons. The F4U-4, equipped with the more powerful Pratt & Whitney R2-80018W engine producing 2,100 horsepower, boosted to 2,450 horsepower with water alcohol injection. This engine was paired with a more efficient 4-bladed propeller that could better transfer power into climb performance. The numbers were extraordinary. The F4U-4's maximum climb rate at sea level exceeded 4,000 feet per minute. With water injection engaged for emergency power, some test flights recorded climb rates approaching 4,360 feet per minute. This was not incremental improvement. This was transformative performance that exceeded almost every fighter in the Pacific, American or Japanese. For comparison, the Zero's climb rate remained around 3,000 feet per minute. The Nakajima Ki-84 Hayate, one of Japan's best late-war fighters, could manage approximately 3,790 feet per minute. Even these improved Japanese designs found themselves outclimbed by the new Corsairs. The American fighter could ascend at rates 30 to 40% higher than its opponents. What this meant in practice was devastating. Japanese pilots engaging F4U Corsair discovered that vertical combat was no longer just disadvantageous, but essentially impossible. A Corsair pilot who chose to climb could not be followed. A Corsair pilot with altitude could dive, attack, climb back to altitude, and repeat the process indefinitely. Japanese fighters attempting to counter these tactics found themselves perpetually at an energy disadvantage, unable to catch American aircraft operating in 3 dimensions with impunity. Combat reports from late 1944 and 1945 describe Japanese pilots' growing frustration. One engagement over the Philippines in late 1944 saw a formation of Ki-84 fighters attempt to intercept a group of F4U Corsairs escorting bombers. The Japanese formation climbed to intercept, expecting to use their altitude advantage. But as they closed, the Corsairs simply pulled up into steep climbs, ascending through the Japanese formation and establishing position above them before the Japanese pilots could react. The Ki-84 pilots attempted to follow, pulling their aircraft into maximum climb. For a few moments, they gained on the Corsairs. Then the American fighters began pulling away, climbing faster despite their heavier weight. The Japanese pilots pushed their throttles to emergency power, straining their engines, but the gap continued to widen. By the time the Corsairs leveled off and turned back to engage, they held both altitude and speed advantages. The Japanese pilots, their aircraft now low on energy from the attempted climb, had no choice but to dive away. This pattern repeated across the Pacific theater as F4U Corsair entered service in growing numbers. At Okinawa in the spring of 1945, Corsair pilots developed tactics specifically designed to exploit their climb advantages. They would patrol at medium altitude, waiting for Japanese aircraft to appear. When contact was made, they would engage with brief firing passes, then immediately zoom climb to regain altitude. Japanese interceptors attempting to follow found themselves watching the Corsairs ascend out of reach. The technical reasons for the Corsairs' climb dominance were rooted in fundamental engineering principles. Climb rate is determined by excess power, the difference between the power required to maintain level flight and the total power available from the engine. The Corsair's massive R2800 engine provided enormous amounts of excess power across its flight envelope. At sea level, the F4U weighed approximately 12,400 pounds in combat configuration. Its engine produced 2,450 horsepower with water injection. This gave it a power-to-weight ratio that exceeded almost every operational fighter in the Pacific theater. The 4-bladed propeller transferred this power efficiently into vertical velocity. The clean aerodynamic design minimized drag, allowing more engine power to translate into climb performance rather than being wasted overcoming air resistance. Japanese fighters, by contrast, had been designed around different priorities. The Zero achieved its legendary maneuverability and range through extreme weight reduction. The A6M20 weighed just 3,704 pounds empty, compared to the Corsair's nearly 9,000 pounds. But this came at a cost. The Zero's Nakajima Sakai engine produced only 940 horsepower. Even later, Zero variants with more powerful engines could not approach the Corsair's power levels. The Ki-84 Hayate, introduced in 1944 as Japan's answer to improved American fighters, represented Japanese aviation at its peak of wartime development. It had armor protection, self-sealing fuel tanks, and a powerful Nakajima Ha-45, an engine producing 1,800 horsepower. Its climb rate of approximately 3,790 feet per minute made it one of the best climbing Japanese fighters of the war. But even the Ki-84 could not match the F4U. The American fighter still held a climb advantage of 600 to 700 feet per minute, roughly 20% better performance. In combat, this translated to Corsairs gaining 120 to 140 feet of altitude every 10 seconds, compared to pursuing Japanese fighters. Over the course of a 1-minute climbing engagement, if you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Corsair would pull 700 feet higher than a Ki 84, 1,200 feet higher than a Zero. Japanese pilots described the experience with a mixture of technical precision and emotional frustration. Captured documents from late 1945 revealed debriefings, where surviving pilots reported that engaging Corsairs in vertical combat was futile. The American fighters could climb away from any Japanese aircraft, they could control the altitude of combat, they could dictate when and where engagements occurred. Japanese pilots found themselves forced to fight on American terms, or not fight at all. One particularly detailed report came from a Japanese Navy pilot who survived an engagement over Okinawa in April 1945. He described encountering a formation of 4 Corsairs while flying a Zero. The Japanese pilot had altitude advantage initially, perhaps 1,000 feet above the American aircraft. He rolled into an attack dive, closing rapidly on the trailing Corsair. As he approached firing range, the American formation broke, each Corsair pulling into a steep climb in a different direction. The Japanese pilot committed to one target, following it upward, confident that his lighter aircraft could follow the climb long enough to get a firing solution. For the first few seconds, he closed slightly. The Corsair was in his gun sight, climbing at what seemed like a steep but achievable angle. He prepared to fire. Then the Corsair's climb steepened further, the nose pointing almost vertically. The big radial engine's roar echoed across the sky as the American pilot engaged emergency power. The Japanese Zero followed, pulling its nose up as high as it would go. The aircraft shuddered at the edge of a stall. The pilot fought to keep the nose up, his airspeed bleeding away rapidly. Above him, the Corsair continued climbing, pulling away not gradually but quickly, decisively. Within 10 seconds, the American fighter had opened the gap from 200 feet to 500 feet. Within 20 seconds, the Corsair was 700 feet above him and still accelerating upward. The Japanese pilot's Zero reached its maximum climb angle, the aircraft wallowing on the edge of controlled flight, speed dropping below 100 miles per hour. He could no longer keep the nose pointed at his target. He had no choice but to push the nose down, recover airspeed, and abandon the attack. Above him, the Corsair leveled off, rolled inverted, and dove back down, now holding every advantage: speed, altitude, energy. The Japanese pilot dove away, using his Zero's superior ability to tolerate high G-turns to evade the counterattack. He survived, but the lesson was clear. The Americans had built a fighter that dominated vertical combat completely. When he returned to base and filed his combat report, he used a specific phrase that would appear in other Japanese pilot accounts. The Corsair's climb performance was impossible for a carrier-based fighter. It violated what Japanese pilots understood about the relationship between weight, power, and performance. This word, impossible, appeared repeatedly in Japanese assessments of the Corsair. Not impossible in the literal sense, but impossible according to the design philosophy that had guided Japanese fighter development. Japanese engineers had believed that climb performance required light weight above all else. The Zero had demonstrated this principle brilliantly by reducing weight to an absolute minimum, eliminating armor, using lightweight structures. Japanese designers had created fighters that climbed superbly despite relatively modest engine power. The Corsair proved that another path existed. With enough power, a heavy fighter could outclimb a light fighter. With enough excess horsepower, armor, self-sealing tanks, heavy guns, and robust structure could coexist with exceptional climb performance. The Americans had not just matched Japanese climb rates, they had exceeded them while building an aircraft that was simultaneously faster, tougher, more heavily armed, and longer ranged. For Japanese aviation, this represented a crisis in understanding. Throughout the war, Japanese designers had worked within constraints imposed by limited industrial capacity and material shortages. Engines could not be made arbitrarily powerful. High-grade aluminum alloys were in short supply. Skilled labor grew increasingly scarce as the war ground on. Japanese fighters reflected these constraints, achieving excellent performance through clever design and weight reduction rather than overwhelming power. But the Americans faced no such constraints. Their industry produced high-octane aviation fuel in unlimited quantities. Their metallurgy was sophisticated enough to build engines that operated reliably at power levels Japanese designers could barely imagine. Their manufacturing quality ensured that aircraft performed consistently to specification rather than suffering from the production defects that plagued late-war Japanese fighters. The Corsairs' climb performance embodied these advantages. A Japanese pilot facing an F4U was not just fighting a better aircraft. He was confronting the industrial might of a nation that could design, build, and deploy fighters with performance characteristics that simply could not be replicated by Japanese industry. The gap between what Japanese pilots flew and what they faced was not merely technical, it was philosophical and industrial. By mid-1945, American fighter doctrine in the Pacific had evolved to fully exploit the Corsairs' vertical capabilities. Training manuals explicitly emphasized altitude management and energy fighting. New pilots arriving in theater received instruction that would have seemed counterintuitive earlier in the war. Do not attempt to turn with Japanese fighters. Do not engage in prolonged dogfights. Use speed and climb to control the engagement. Fight in the vertical dimension where American power advantages dominated. This represented a fundamental shift from the fighter tactics that had governed air combat earlier in the war. In 1942 and early 1943, American pilots often found themselves forced to fight on Japanese terms. Their aircraft lacked the performance to simply refuse combat. If a Zero wanted to engage, American pilots had limited options to disengage safely. They fought in turning battles where Japanese maneuverability often prevailed, or they tried to use diving speed to escape, hoping Japanese pilots would not or could not follow. The Corsair, particularly the F4U variant, eliminated these constraints. A Corsair pilot could refuse any fight that did not favor his aircraft's strengths. Japanese fighters attempting to force combat found themselves simply unable to catch Corsairs that chose to climb away. Even when Japanese pilots achieved surprise attacks, diving on Corsairs from above, American pilots could often survive by pulling into steep climbs that their pursuers could not sustain. The tactical manual for the F4U, distributed to Marine and Navy squadrons in early 1945, included specific guidance on using climb performance in combat. If bounced from above, the manual advised, do not attempt to turn. Instead, apply full power, including water injection, establish a climb angle of approximately 45 degrees, and maintain climb speed around 180 miles per hour. This would produce maximum climb rate, allowing the Corsair to either match or exceed the altitude of most attacking aircraft within 30 to 40 seconds. If engaging Japanese fighters at equal or superior altitude, the manual recommended diving attacks followed by zoom climbs. Dive at full power to maximize speed, close to firing range, fire a burst of no more than 2 or 3 seconds, then pull up into a steep climb using the accumulated speed. Climb at least 1,000 feet above the combat area before turning back for another attack. Never remain at the Japanese fighter's altitude longer than necessary to complete the firing pass. These tactics worked because Japanese fighters simply could not counter them. A Zero pilot watching a Corsair zoom climb after an attack might attempt to follow, but within seconds the altitude difference would grow beyond the Zero's ability to close. The Japanese pilot could try firing at extreme range, but deflection shots against a rapidly climbing target were nearly impossible. He could dive away to build speed for his own zoom climb, but by the time he regained energy, the Corsair would already be repositioning for another attack. Combat over Okinawa in April, May, and June of 1945 provided the most extensive testing of these tactics. Corsairs from Marine squadrons and Navy carriers flew thousands of sorties, engaging Japanese fighters attempting to protect kamikaze attacks on the American fleet. The numbers told a stark story. Corsairs achieved kill ratios exceeding 10-1 against Japanese aircraft. Many Marine pilots racked up multiple kills in single missions, using vertical tactics to engage, disengage, and re-engage at will. Major Robert M. Hansen of Marine Squadron VMF 215, flying an F4U earlier in the war, had already demonstrated the effectiveness of vertical tactics in the Solomon Islands. On January 20th, 1944, Hansen encountered a formation of Japanese aircraft near Rabaul. Rather than engaging in a turning fight, he made repeated diving attacks, firing brief bursts and climbing away each time. Over the course of 15 minutes, he shot down 5 Japanese aircraft without taking a single hit himself. He survived each attack by climbing away before Japanese escorts could effectively counterattack. If Hansen's success in an F4U was impressive, the performance of pilots flying F4U seconds bordered on the overwhelming. Captain Kenneth Walsh, who had been the first Corsair ace back in 1943, returned to combat in 1945, flying the new variant. He described the F4U as transforming the nature of combat. In the earlier Corsairs, he explained, "You could climb away from most Japanese fighters, but it required careful energy management. In the F4U, you could climb away from anything, decisively and quickly." Walsh recalled a specific engagement over Okinawa, where his division of 4 F4U seconds encountered a mixed formation of approximately 20 Japanese fighters, including Zeros, Ki 84 seconds, and N1K2J Shidenkais. The Japanese formation had altitude advantage, perhaps 2,000 feet above the Corsairs. In the earlier war, this would have been a desperate situation. 20 enemy fighters with altitude advantage against 4 American aircraft would have forced the Americans to either fight at severe disadvantage or attempt to run. Walsh instead ordered his division to climb, not away from the Japanese formation, but directly toward it, climbing at maximum rate with water injection engaged. The Japanese formation, surprised by this aggressive response, hesitated for a few crucial seconds. By the time they committed to diving attacks, the Corsairs had already gained 1,000 feet of altitude and were still climbing at over 4,000 feet per minute. The Japanese fighters dove, picking up speed, but the Corsairs continued climbing through their attacks. The Japanese pilots fired as they passed, some scoring hits, but none could slow enough to follow the climb without stalling. Within 30 seconds, the Corsairs had climbed through the Japanese formation and established position 2,000 feet above them. The altitude advantage had completely reversed. Walsh's division rolled into diving attacks from above, now holding every tactical advantage. They shot down 6 Japanese fighters in the first pass. The remaining Japanese aircraft scattered, attempting to escape. Walsh's Corsairs pursued, making repeated diving attacks followed by zoom climbs. Each time Japanese fighters tried to counterattack, the Corsairs simply climbed away and repositioned. The engagement lasted perhaps 8 minutes. By the end, Walsh's division had claimed 11 confirmed kills with no American losses. This engagement, recorded in official combat reports, represented the full realization of vertical fighting doctrine. 4 American fighters had turned the tables on 20 Japanese aircraft through superior climb performance. What should have been a desperate defensive battle became a one-sided slaughter because the Corsairs could operate in 3 dimensions, while Japanese fighters were effectively constrained to 2. Japanese pilots who survived such encounters filed reports expressing confusion and demoralization. How were they supposed to fight aircraft that could simply climb away from any threat? Traditional fighter tactics emphasized gaining altitude before combat, attacking from above with speed and surprise. But Corsairs negated altitude advantage by out-climbing their attackers. They negated surprise by being able to escape upward, even when caught at disadvantage. Some Japanese pilots attempted to develop counter-tactics. One approach was to attack in coordinated waves, hoping that multiple simultaneous attacks would prevent Corsairs from climbing away cleanly. This sometimes worked to keep Corsairs at lower altitudes, but it required numerical superiority and careful coordination. By mid-1945, Japanese forces rarely achieved either. Pilot quality had deteriorated as experienced aviators were killed and replaced by hastily trained newcomers. Radio equipment was poor or non-existent on many Japanese aircraft. Coordinated tactics broke down quickly in the chaos of combat. Another attempted counter was to use the Ki-84, Japan's best climbing late-war fighter, specifically as interceptors against Corsairs. Ki-84 units received instructions to maintain altitude advantage and to dive on Corsairs with enough speed that they could complete attacks and climb away before American aircraft could respond. This represented an attempt to use vertical tactics against the Corsairs, fighting them with their own methods. It achieved limited success. Ki-84 pilots with good positioning and surprise could sometimes make effective diving attacks on Corsairs. But even the Ki-84's climb rate of 3,790 feet per minute was insufficient to allow repeated attacks. After one or two diving passes, Corsairs would have climbed to match or exceed Ki-84 altitude. The engagement would then favor the more powerful American aircraft. Moreover, Ki-84 seconds suffered from severe mechanical problems by late 1945. Poor quality materials, inadequate maintenance, and manufacturing defects meant that many Ki-84 seconds could not achieve their rated performance. Engines failed, landing gear malfunctioned, fuel systems leaked. American pilots encountering Ki-84 seconds noted that while well-maintained examples were formidable, many Japanese fighters showed obvious signs of poor condition. Engines emitted smoke, aircraft struggled to maintain formation, performance was often well below specification. The Corsair, by contrast, benefited from American industrial quality control and robust design. While the F4U-4's more powerful engine required careful maintenance, particularly the water injection system, American ground crews had the training, tools, and spare parts to keep aircraft operational. Combat squadrons typically maintained availability rates exceeding 70%, meaning that most aircraft were combat-ready most of the time. Japanese squadrons, by comparison, often struggled to keep half their nominal strength operational. This reliability advantage compounded the performance advantage. Not only could Corsairs outclimb Japanese fighters when both were functioning properly, but Corsairs were far more likely to be functioning properly. A Japanese pilot flying a well-maintained Ki-84 might hope to compete with a Corsair in vertical combat, though still at disadvantage. But if his aircraft suffered from the fuel system problems, engine reliability issues, or control surface defects that plagued late-war Japanese production, he stood no chance whatsoever. The psychological toll of facing Corsairs mounted steadily through the spring and summer of 1945. Japanese pilots increasingly described a sense of helplessness. They could not turn with Corsairs because American pilots refused to engage in turning fights. They could not dive away because Corsairs were faster. They could not climb away because Corsairs climbed better. What tactical options remained? Some pilots simply stopped engaging when they encountered Corsairs. Combat reports from American units noted that Japanese fighters would sometimes break off attacks when Corsairs appeared, even when the Japanese held numerical advantage. This was not cowardice, but realistic assessment. Engaging Corsairs without significant advantage meant high probability of being shot down with little chance of inflicting damage in return. Experienced Japanese pilots, now rare and valuable, learned to pick their battles carefully. This defensive mindset represented a complete reversal from early war Japanese doctrine. In 1941 and 1942, Japanese pilots had been aggressive to the point of recklessness, confident in their aircraft's superiority and their own skill. They sought combat, accepting risks because they believed they held advantages that ensured victory. By 1945, that confidence had evaporated. The appearance of the F4U Corsair in the final months of the war, though too late to see significant combat, represented the pinnacle of American fighter development in World War II. This variant, first flown on December 21, 1945, featured an even more powerful engine, the Pratt & Whitney R280032E, producing 2,760 horsepower. Its climb rate exceeded 4,850 feet per minute at sea level. Had the war continued, Japanese pilots would have faced Corsairs that could climb nearly 60% faster than Zeros, 50% faster than Ki 84 seconds. The performance gap would have been insurmountable, but the war ended in August 1945 before F4U 5 seconds could deploy operationally. The atomic bombings of Hiroshima and Nagasaki, combined with Soviet entry into the war, brought Japanese surrender before this ultimate Corsair variant could demonstrate its capabilities in combat. In the years after the war, captured Japanese aviation personnel participated in Allied technical interrogations. American intelligence officers wanted to understand Japanese perspectives on Allied equipment. When questioned about the Corsair, Japanese pilots and engineers offered consistent assessments. The aircraft was extraordinary. Its combination of speed, firepower, durability, and climb performance exceeded anything Japanese aviation had fielded or could have fielded, given Japan's industrial constraints. One Japanese Navy pilot, speaking through a translator in late 1945, was asked what he found most intimidating about the Corsair. He thought for a moment, then said that it was the climb. Other American fighters were fast or well armed, but the Corsair could climb, and that meant it controlled the sky. When you fight aircraft that climb better than yours, he explained, you cannot dictate the terms of combat. You cannot escape, you cannot hide. You fight when and where the enemy chooses, or you do not fight at all. This statement captured the essential nature of the Corsair's tactical advantage. Climb performance translated directly into combat control. Altitude could be converted into speed through diving attacks. Speed could be converted back into altitude through zoom climbs. A fighter that climbed better than its opponents could maintain this energy cycle indefinitely, attacking and escaping at will. Japanese fighters, unable to match these performance levels, were forced into reactive rather than proactive combat. Japanese engineers examining captured Corsairs after the war studied the aircraft with mixture of professional interest and acknowledgement of defeat. They measured the massive R2800 engine, noting its sophisticated supercharger system and robust construction. They examined the four-bladed propeller, recognizing the engineering challenges of designing blades that could efficiently transfer such enormous power. They analyzed the inverted gull wing, understanding how it balanced ground clearance needs with aerodynamic efficiency. What they found confirmed what their pilots had reported. The Corsair was not just well designed, but represented design philosophy fundamentally different from Japanese practice. Where Japanese engineers had pursued performance through weight reduction and aerodynamic refinement, American engineers had pursued performance through overwhelming power. Where Japanese design accepted compromises necessitated by limited resources, American design assumed unlimited access to high-grade materials, sophisticated manufacturing, and powerful engines. The technical reports written by these Japanese engineers, discovered in archives after the war, show clear understanding of what had defeated them. The Americans had not simply built better aircraft. They had built aircraft that embodied industrial capabilities Japan could not match. The Corsair's climb performance was not the result of one clever design choice, but the product of an entire industrial system operating at levels Japan never achieved. By the end of World War II, the F4U Corsair had compiled a remarkable combat record. The aircraft achieved an 11-to-1 kill ratio against Japanese aircraft. Of the more than 2,140 Japanese aircraft claimed shot down by Corsair pilots, many were destroyed in vertical engagements where Japanese pilots had no effective counter. The Corsair's pilots included some of America's highest-scoring aces. Its missions ranged from fighter sweeps to ground attack to kamikaze interception, but perhaps its most significant contribution was psychological rather than quantitative. The Corsair demonstrated to Japanese pilots that American aircraft could dominate in dimensions beyond just speed and firepower. Climb performance, once considered a Japanese strength, became an American advantage. The vertical dimension of combat, once considered favorable terrain for Japanese fighters, became a killing ground, where Corsairs hunted with impunity. For Japanese survivors of the Pacific Air War, memories of the Corsair remained vivid decades later. In interviews conducted in the 1970s and 1980s, former Japanese pilots described their experiences facing American fighters. When discussion turned to the Corsair, the word that appeared repeatedly was formidable. The Corsair was formidable not because of one characteristic, but because it excelled in every aspect of performance that mattered in combat. One former Zero pilot, interviewed in 1983, recalled his first encounter with a Corsair in late 1944. He had been briefed that the American fighter was fast and well-armed but heavy and unable to climb or turn effectively. When he actually engaged Corsairs, he discovered that every part of that briefing was wrong except the part about firepower. The Corsairs were indeed heavily armed, but they were not sluggish. They climbed magnificently. They could turn well enough when they chose to turn, though they rarely did because they did not need to. He survived the war, he explained, by learning to avoid Corsairs whenever possible. When forced to engage them, he made single attacks and disengaged immediately, never trying to follow through or pursue. He watched less experienced pilots try to dogfight with Corsairs and saw them shot down. The ones who survived, he said, were the ones who understood that the American fighter controlled the battlefield and fought accordingly. The Corsair continued serving long after World War II ended. In the Korean War, from 1950 to 1953, Corsairs flew thousands of ground attack missions, their climb performance less relevant in that conflict, but their bomb-carrying capacity and durability invaluable. The aircraft remained in production until 1952, with more than 12,000 examples built. Foreign air forces flew Corsairs through the 1960s, with the final combat missions occurring during the brief soccer war between Honduras and El Salvador in July 1969. But it was in the Pacific War, from 1943 to 1945, that the Corsair wrote its most significant chapter. It was there that American engineers' decision to build around the most powerful engine available, to pursue performance through overwhelming power rather than weight reduction, proved its value. It was there that the distinctive bent-wing silhouette became synonymous with American air superiority. The climb rate that shocked Japanese pilots represented more than just technical superiority. It represented a nation's industrial capacity, its ability to design and build aircraft that exceeded what opponents thought possible. When a Corsair pilot pulled back his stick and pointed his nose skyward, climbing at rates that Japanese fighters could not match, he demonstrated not just his aircraft's power but his nation's power. The sky belonged to whoever could climb highest, fastest, and when Corsairs arrived, that meant the sky belonged to America. For Japanese pilots who fought through those final years of the war, watching Corsairs climb away from them again and again, the lesson was unmistakable. They had entered the war confident in their aircraft's superiority. They ended it understanding that American industry had produced fighters that dominated in every dimension of combat. The Corsair's climb performance was just one measure of that dominance, but it was a particularly visible and psychologically devastating one. In the story of World War II aviation, the F4U Corsair stands as a symbol of American engineering philosophy and industrial might. The fighter that climbed when Japanese pilots said it was impossible, the fighter that controlled the vertical dimension of combat through sheer power and sophisticated design, the fighter that turned the Pacific sky into an arena where American advantages in power, manufacturing quality, and tactical innovation combined to devastating effect. Japanese pilots never expected fighters to climb 3,000, 4,000, nearly 5,000 feet per minute. They never expected carrier-based aircraft to combine that climb performance with speed, range, firepower, and durability. They never expected to face aircraft so superior that their only viable tactic was to avoid combat whenever possible. But the Corsair was built for exactly that. It turned expectations into obsolescence and assumptions into losses. From the first engagements over the Solomons to the final battles over Okinawa and the Japanese home islands, it demonstrated that when American engineers decided to build a fighter around maximum power, the result was an aircraft that could dominate combat in ways Japanese aviation could never counter. The bent-wing bird that climbed like nothing else in the Pacific sky, the fighter that made impossible into reality. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.